Hello everyone. Let us start with today's lecture on two-dimensional arrays. In the last lecture, we have covered in detail about one-dimensional arrays. So today, we will see how the declaration of two-dimensional arrays are used and how to initialize them and how to identify when to use which type of arrays. Let us begin. Okay, so to begin with, the declaration is fairly simple, same as the way we declare the one-dimensional array. The only difference is now there are two more subscripts. Now, what do you mean by subscripts? So that array, whatever is inside the square brackets, these are called subscripts. Okay, so in one-dimensional array, there is one subscript, and in two-dimensional array there are two subscripts. The first subscript is known as the row, and the second subscript is known as the column. Okay, so basically whenever we define two-dimensional array, we are actually defining what is the size of the array in the form of number of rows and number of columns. Okay, like for example, let us suppose we want to store data of 5 students, and that data is about 5 subjects. Then in that case we will declare an array something like this. Here the type of the array is int, the name of the array is students, and the number of rows is 5, number of columns is 5. Okay, now what this rows and columns signify, it completely depends on the programmer. Okay, so one may think that this is the number of students and the column is the number of subjects, or another programmer may decide this as number of subjects, that is the row as the number of subjects and the column as number of roll number of the students. So it completely depends from programmer to programmer. Okay, so the only this is how we declare a two-dimensional array. Now if you look at it visually, this is how it will look. So here I have declared a 3 cross 3, that means 3 rows, 4 columns array. So this is how it looks like. So if you look at the first element, so this is nothing but 0 cross 0. Okay, so why it is 0 cross 0 is because it is at position 0. The first row, our numbering starts from our index of our arrays, as we have seen in one dimensional array, the index starts from 0. So row 1 the index is 0, row 2 the index is 1, and row 3 the index is 2. Similarly, column 1 the index is 0, column 2 the index is 1, column 3 the index is 2, and so on. So the first element will have the index 0 comma 0, that means the first row, first column, right? And in the second, it is in the same row, but the column is the second column, that means index 1. Okay, the third one, it is again the same row, but the column is 2. So like that. And over in this case, if you go down, you will see the row has changed, but the column is remaining the same. Okay, so it is row number 2, that means index of row 2 is 1, that's why x of 1, and column 1, that means index of column 1 is 0, so that's why it is x1 0. So this is just to visualize how an array is numbered. Okay, so next let's go ahead. Now this is very important to identify when to use one-dimensional array and when to use two-dimensional array. So I will just give you certain scenarios where which will help you to identify how which arrays to use where. So this is the first use case. So in the first one, it is saying you want to have an array to store marks of 5 students. So in this case, it is one-dimensional array. Why? because you have 5 students and every student will have some marks, right? So I do not have any other level, right? So I will have an array, one dimensional array called marks of size 5. So every number, every variable, every subscript will identify the roll number of the student. Okay, so like for example, marks 0, that means it is the first student. Marks 1 will be the marks of the second student. Like that it will go on. So again, you should remember the index starts from 0 over here. Okay, the second use case, let us suppose we want to store an array of marks of 5 students in 5 different subjects. You can look at the wordings over here. You have to store 5 students marks in 5 different subjects. So in this case, there is 2 levels in the array, so that we can identify it something like this. It is the same array, but right now we have 2 subscripts. The first subscript is of size 5 because we have 5 students, and the second subscript is of size 5 again because we have 5 subjects. Now this 5 students and 5 subjects, in the first case, if you look at the first case, it completely depends on programmer whether you want to set the row as the student's number or the column as the student's number. Okay, so let's say in the first use case, one of the programmers did in this way. That means the first subscript is for the students, so basically there are 5 students, and the second subscript is for 5 subjects. So this is absolutely fine. A second programmer may think in a slightly different pattern. He would say, no, I want to have the first, that is row, as subjects and the column as students. So it actually doesn't matter in which orientation you select the subscripts. Only the matter is you should have both the subscripts included in the array. So that's why the point here to note is, when you have multiple level hierarchies, you should switch to multi-dimensional arrays, or to in our case, in this particular example, 2-dimensional array was required. Okay, so let's take another example. Let's suppose some voting is going on and you want to store the votes of 10 candidates. So in this case, you want to just store the count, the number of votes a particular candidate has received. And here I have told you there are 10 candidates, so simply I will create an array of 10. So basically votes of 0 is, that means the first candidate will it will be storing the votes of that particular candidate. So like that, votes of 1 will be storing the second candidate's votes. Like that, this will be using 1-dimensional array. Now similarly, let's look at the another use case. Let's say I want to store votes of 10 different parties in 5 states. Okay, so I want to again store votes, but in this case 10 different parties votes have to be stored, and that too in different states, in 5 different states. So basically in here you can see there is a multiple hierarchy over here. So there are parties and there are states, and for these parties and these states we have to count the votes. So in this case, the value is actually the votes and the subscripts are the parties and the states. So again we have to switch to 2-dimensional arrays. So in this case, again, if you look at it, there are 2 ways of doing this. The first programmer may take the row as the parties. So in that case we should have 10 parties, so the row is 10, and column is 5 states, so 5 is the column. Okay, the second programmer may think in a slightly different fashion, and he would select the row as states and the column as the parties. So again, in both the cases the result will be the same. Okay, slightly the programming will change, but the final result will be the same in both the scenarios. Okay, Okay, so now let us see how to initialize these arrays, that is two-dimensional arrays. It is same as the previous one. Okay, so it is basically the declaration. This part is the declaration, and that this the assignment operator, and then in the curly braces you just provide the list of values separated by comma. Okay, so this is one example. I have given you the same thing in three different versions. Okay, so all the three versions are acceptable, and the I would personally prefer the last one, that is the third one, third method, because that is a bit more intuitive to identify which part of the array is going where. Okay, like for example, in this in this particular case, if you look at it, in the first example, all the elements are given in one sequence in one go, right? So there is basically so whenever the entry, if you look at the note over here, it says the array initialization is always done row by row. That means the first row is completed first, and then the second, and then the third, right? So in if you look at this array status is of size 3 cross 2. When I say 3 cross 2, it means there are 3 rows and 2 columns, right? So when you give value something like this, then how the value is going to be entered into the array is row by row. That means the first two elements will be taken in and put into the first row. Okay, so first row, this will be the second row, and this will be the third row. So this is how so it will be entered row by row. So the same thing, now here we are not clear as to how it is being entered, because we know this node, this we know how it works, so that's why we definitely know that it is entered row by row. But there is a this second syntax is much more clearer in terms of how the values are entered. So here we are saying that it's an array by saying it's a curly braces, and inside that we are telling that the first row has values 1 comma 1, the second row has values 2 comma 2, the third row has values 3 comma 3. So we are separating each row with again sorry each column each row with curly braces again. So this is a good practice to do it in a single line. The third one is exactly similar to the first one. The only difference being that I have used additional carriage returns over here just to separate out the way it looks. So this looks much more like an matrix. So this helps us identify what is the row and what is the column. So if I say where is this 2 lying? So it is basically in the second row, second column. So it is simply just to visualize the array that we write in this particular format. So I personally prefer that people, if you are initializing, you should initialize in this method. Okay, then again look at the second note that I have written over here. Second note says that partial initialization is possible. Like in one-dimensional arrays, here also we can initialize partially, like we can initialize a few of the elements, and the remaining elements will be initialized automatically by the rule that we have already stated, that if it is a numeric value, then it will be initialized to 0, and if it is character value, it will be initialized to null. Okay, and the third note, the last note, is that it is just to remind you that whatever is inside the square brackets, those are called subscripts, and those subscripts should be always integer values. Okay, so let us go to the next. Now this is very important, the memory layout of arrays. Okay, so now basically how is array stored inside your memory? Okay, so as soon as you compile and you run the program, some amount of memory is stored, memory is used by your program to store these arrays. Okay, so this is called as static memory allocation, because you already mentioned the size of your arrays uh, while doing programming. Like in our case, in this particular case, I have already mentioned that my size of the array is 3 cross 2, right? So that means I'm here I'm doing static memory allocation. Okay, so there is another way of allocating memory which is called as dynamic memory allocation. So that is a much more advanced topic. We are not covering it in this particular lecture. We may cover it in the future lectures. Okay, so now how does a memory layout work? So memory, whenever we store arrays inside our memory, it is stored in a sequential form. Okay, so basically if you can look over here, so this you can see over here, this is the address, the one sorry, 10,000 is the address of this is the name of the variable int array, and this is the index, that is a subscript of your array. So this array starts at this particular location, and then the next array starts at the memory location 4, the 10,004. Now why 4? Because this is of type int, and int, you may remember, it uses 4 bytes of memory. So this 10,000 corresponds to 1 byte, so it will require 4 bytes. So the next memory will start at 10,004, and in the next index, that is the third index, will start at again 10,008. That is, add 4 to the previous block and you will get the next block. Similarly, add again 4 to the previous block, you will get 10,012. So this is how the arrays are stored inside your memory. Okay, similarly, if you look at two-dimensional arrays, this was for one-dimensional array. For two-dimensional array, the same concept is used, but in this case the rows are stored first. Okay, so if you look at this, the first row, that is index 0, first row, first column is the first element. That means 0 0 will be always the first element. The second element will be 0 1. That means you will finish off all the rows first. Okay, so 0 1, then 0 2. Then once the rows are finished, then we will go for 1 0. That means second row, first column, then second row, second column, and second row, third column. So like this. So then in the next element we will go for the third row, first column, third row, second column, and third row, third column. So if you look at this, this is how the memory is mapped onto our RAM when it is being executed by the user. Okay, so let us now start with the programming examples, how to use arrays in some simple programs. Before that, I would like to show you how give you a live demo of how memory allocation works. I have written a simple program over here. I have initialized one variable a equal to 1, and I have initialized another variable which is ab, which is actually an array of size 5. Okay, and what I have done is I just want to print the address at which this variable is being stored in the memory. Now when you should remember that whenever we use and in front of a variable, it does not give you the value, but it gives you the address of that particular variable. Okay, so I want to print the address of a, that's why I have added and in front of it. Similarly, if you look at it, this is the array, the first index, and I am finding out what is the address of that particular array. Similarly for the second element and for the third element. There are two more elements, I am not interested in those. And also I am printing out the size of the integer array. Okay, so let us just run this code and see the result. Okay, so the first one says that the address of a is at 6422268. This is the address, and the size of A is 4 bytes. Okay, so basically integer requires 4 bytes of memory. Now look at this is the interesting part. Look at the size of the array, sorry, address of the array. The first element started at 642248. Okay, 642248, and look at the address of the next element in the array. So next element is 642252. If you see, it is a continuous block. That means after 64222 it was 48 and this is 52, and if you look at it, the difference is of 4. That means the if you can look at it, this is an integer. That means this AB of 0 required 4 bytes. That's why the next address of the element will start after 4 bytes. That's why after 48 it started at 52, and after that it will again start with next 4 bytes. That means 52 plus 4, that is 56, right? So similarly it will go on. So it will take up 4 bytes for every element till the size of the element is reached. Okay, just to show you how the memory is allocated. Okay, so I will just stop this over here, clear this out, and start with our program. Okay, so the first program that we have is, it says find the transpose of the matrix, 3 cross 3 matrix. Okay, so first of all, what we have to do over here, the first thing that we have to do over here is take the input from the user of a matrix of size 3 cross 3. Okay, so let us first declare the matrix int. Let's say the name of the matrix is A, the size is 3 cross 3. Okay, so I have done that. Now let us get the values of A from the user. Now to get the values of A, you can do multiple things. Now I will show you 2 methods of how to get the values from the user. You are free to use whichever you like. Okay, so now before starting with how the values we have to get the values from the user, you should understand that what is the aim of our program. Aim of a program is basically to find the transpose, and you must already be knowing what is a transpose. We are basically you just have to swap the rows with the columns. That is nothing but the transpose. Okay, so first let us take the input. So to take the input, what you can do is simple scanf. Okay, so before that I will just write inform the user that they should enter. So enter the values of the matrix. Okay, so once that is done, I can do a simple scanf %d and %d %d %d. So it is 3 4 %d 5 6 7 8 sorry 8 and 9. So because it is a 3 cross 3 matrix, there will be 9 elements. So 1 2 3 4 5 6 7 8 9. Okay, and then ampersand sign. Then the first %d will be for index 0 / 0. The second will be for, so I can just copy these over here. I can copy this multiple times, and I will just change this. This is 0 1 0 2, then this will become 1 0, then this will be 1 1 1 2 1 sorry 2 0 2 1, and I think I have to add one more. Okay, one more, and this will be 2 2. Okay, so that's it. So I have taken the values of all the values. So now all I have to do is change the rows into columns and columns into rows. So to do this, it's very simple. So always remember, when you have a two-dimensional array, you will have a nested for loop. So let us begin. So let's add a for loop. And so because one for loop will be for the row and one for loop will be for the column, right? So I should have two counters for it. So I will just initialize those two counters, declare those two counters I and j. So let us start. So I equal to 0, because our index of the array starts from 0 and ends at 2, right? So that means less than 3. So I less than 3, that means I will start from 0, 1, 2, that means 3 values. Okay, then I plus plus. So this will be for the rows, right? Now we need another for loop for the columns. So now columns will be starting from j. So j equal to 0 to j less than again 3, because there are 3 rows and 3 columns. If you can just recall, 3 rows 3 columns, and j plus plus. Okay, so for every row my column will start from 0 and end till 2. Okay, so similarly my rows will also start from 0 and till 2. So now here the only thing left is I have to do the transpose. Now to do the transpose, if I do the transpose on the same array, then it will create an overlapping result. So I should declare array another array called, let's say, b of same size, which will be storing the output. Okay, so the transposed value of a 3 comma 3 will be stored in b 3 comma 3. Okay, so now I can simply say b of I j. So I am just simply interchanging the values, okay, with the a of ji. So if you look at this statement, what I have done is the value at the rows and columns. So I was the row and j was the column. The value at this row and column I am interchanging with the value at this particular column and this particular row. Okay, so let's suppose I will just take an example of, let's say, when I is equal to, this is just an example. Okay, so let's say I is equal to in this particular iteration, let's say I was 2 and at some particular point j was 1. Okay, just assume j was 1. Okay, so what this will look as, okay, so it will look like b of I is 2 and j is 1 will be equal to a of 1 and 2. So if you look at this, we have simply interchanged the rows and columns using this. Okay, so I will just simply remove this. So this finishes up with our transpose. Now only thing remaining is to print the transpose. Now to print it, we can simply write a printf statement. And so after this I will just print the new values, that is b of 0, then b of 0 0, then b of, so I will just copy this out and paste it out 9 times. Okay, so I hope that is enough. Let us start with 0 0, then this will be 0 1, this will be 0 2, then this will be 1 0 1 1, this will be 1 2, then this will be 2 0 2 1 and 2 2. So this is extra. I will just remove this. Okay, so I think this is enough. Okay, now I can run this. Let us see. So let us enter the values 5 4 3 6 7 8 and 3 2 3 1 3. Okay, so I entered. So in our original case it was 5 4 3 as the row, and if you look at this, now it has become a column 5 4 3, and the next one, the next row was 6 7 8, and if you look at this, it is now the column 6 7 8, and the third row was 2 1 3, and now it is this is the column. Okay, now to better understand what is going on, so I can just take this. So it is always better to print what was the state before and after. Okay, so I will just change it to the original array. So A was our original array and B was our transposed array, right? So I will print these out and we will see it together how it looks. I will add a few more slash n's to have a separation. Okay, now I run it again. So let us enter the values 6 7 3 2 1 6 4 3 2. Okay, enter. Now you can see the row has now become the column. 6 6 3 2 1 6 has become a column over here, and 4 3 2 has become a column over here. Okay, so I hope you understood the first problem statement of how to do transpose of a matrix. Let us go to the second problem statement. The second problem statement is how to do matrix addition. Okay, so the matrix addition is pretty simple. So basically we will be taking input from the user. There will be input will be we will be taking two inputs, two matrices from the user, and we have to find out the output, the third matrix, which is the sum of the both matrices, right? So let us first start with declaring the matrices. So I will just start. Should I start with a new problem? Okay, I will just clear this out. Okay, I will clear this out. Let us start. Okay, we will start fresh. Okay, so first we will declare. Now we need two arrays to store the values. Let that be A and B. Okay, now here in the problem statement it is not mentioned what is the size of the array, right? So the size of the array will be entered by the user. Okay, so but then we cannot leave this empty. So what we can do is we can select a size big enough so that we will not run out of space. Okay, so we will handle maximum up till the size of 10 elements in a row and 10 elements in a column. That is the maximum size that we will be going to handle. Okay, so now the second array should be again of size, same size 10, and the output, that is the sum, let us call it as sum is also of the same size 10 cross 10. Okay, so we have three arrays. The first two is the input and the sum will be the output. Okay, so the first thing that we have to do is find out from the user what is the size of the array. Okay, so basically how many rows and how many columns. And one thing to remember is matrix addition is possible only when all the arrays are of the same size. Okay, so what we are going to do is we are going to ask the user for the number of rows and number of columns. Okay, so let us take two new variables, m comma n, which is basically the m will be the rows and n will be the columns. Okay, so let us take the input from the user. Let us first printf and tell the user enter rows, number of rows. Once I do that, now I can do scanf. Okay, scanf %d because it is an integer type, and we are going to store it at m. Okay, the same thing I'm going to repeat for enter the number of columns, and it will be stored in n. So now we know we have to run for loops. Okay, for how much amount, for we are going to run so basically whenever I have already told you, whenever we have two-dimensional arrays, you should understand there is going to be a nested for loop. Okay, so the first for loop, that is the outer for loop, will be for the rows, and the inner for loop will be for the columns. Okay, so now m and n will tell us what will be the limit of those for loops. Okay, so let us start with the for loops. So the first for loop, so now what we are trying to do is get the input of the matrix elements. Now in the last time we have seen a different method. We have used directly scanf, and we have individually put the values inside the elements. This time we are going to use for loop because we are not sure what the user is going to enter, how many rows and how many columns there are going to be in the array. So that's why this method will help us to handle any size of the elements. Okay, so let us start now. Because there is a for loop, I should have two new variables, counter variables. Okay, so I and j, I for the outer for loop, that is rows, and j for the inner for loop, that is columns. Okay, so these are the limits, rows and columns, and these are the counter variables for the rows and columns. Okay, so let us start. I will always start from 0 because the array's index starts from 0. Okay, I 0, and I should be less than the number of rows entered by the user, and user has entered m number of rows, right? So I should be less than m rows and I plus plus. Okay, so let's write the for loop for columns. It's similarly, so j will also, columns also start from 0, and j should be less than the number of columns entered by the user. Now number of columns is entered by the users is stored in n. Okay, so again j plus plus. So now we have the for loop ready. So now we have to use this for loop to enter the element of a. So we will start we will do a scanf over here. Scanf, simply I will do a %d, and I have to input a. Okay, now here I is the row and j is the column, that is the counter variable. So I will simply replace I and j over here, and so at every iteration it will take one by one every row and column. Okay, so this is done for our input for the first array, right? That is a, right? But this will not look interactive. So to make it a bit more interactive, what I can do is I can just say printf enter values values of matrix, first matrix. Okay, so I have done this, and after that I will do a slash n, and here before putting each and every element, I can do a bit more. I can give a bit more information to the user. The I can say, let's say, um, let me see what I can do. %d, comma %d, and I can say I, comma j. So now what this will do is it will just print the location where this value is going to be stored. Okay, so this I will would like to just run this right now and see if there is any error. Okay, so it is saying number of rows, let us say 2 rows, 2 columns. So it is saying what is the value of 0 comma 0. So I will say 3 2 1, and something has, okay, so it didn't work exactly how I expected it to work. Okay, again I have forgot to add ampersand sign over here to store the data into the variable. I will run it again. So number of rows 2, columns 2, so 3 4 5 and 6. Perfect. So it has taken the first matrix. I will copy this entire thing and paste it again, but this time for the second matrix, and everything will remain the same except for this variable is going to change. Okay, so this is done. So it has taken value for the third one. Okay, so now I will simply copy this out, paste it again, and this time over here I am going to run the same for loop again, but this time I'm going to compute the sum. Okay, so sum is basically sum is equal to a plus b. Okay, but I cannot directly add, right? So it has to be the elements, which elements has to be added one by one, and luckily we have the counter variables. So the first, so basically here if I just put ij, the counter variables, to their respective locations. Okay, so now what happens over here is, so basically what it is doing is, it is in the first iteration. So in the first iteration I is 0, j is 0, so it will be actually sum of 0 cross 0. That means the first element of the sum is actually equal to a of 0 plus b of 0, right? So this is what is happening in the first iteration. In the second iteration, the I remains the same, but j becomes 1. So this will change to 1, this will change to 1, this will change to 1. Okay, so that will give you the second element. Third element, this will, the j changes to 2, so this becomes 2. And in the fourth iteration, I changes to 1 and j becomes 0 again, right? So this becomes I changes to 1, j becomes 0, I changes to 1, j becomes 0, I changes to 1, and j becomes 0. So I think you have understood what I'm trying to say over here. So this is basically how you do matrix addition. Okay, so once this addition is done, now the final step is to print the matrix. Okay, so to print the matrix, I can simply use the same for loop again. Okay, and simply do a printf. Okay, I will simply do a printf %d, and I will simply say sum I and sum j. Okay, and I can do slash t to separate it out. Okay, I think a little bit of interactiveness over here will be helpful. Okay, I will just say the sum is okay. So this much is enough. I will just run this now. Let the number of rows be 2, columns be 2. So the first element 1 2 3 4, and the second 5 6 7 8, and you can see we have got the result. The sum is 6. Now here it is not looking good because we have not we have just used slash t. So if I come after, so basically the inner loop is when that particular all the columns have been processed, right? So after the columns, all the columns have been processed, I should actually put a new line over here after the columns are over. So what happens is, if I run it again, if I put the rows as 2 cross 2, and if I add some values, and you can see now after printing 7 9, then it is doing a new line, and the new elements are printed at in the new line 92 and 11. So if you just check these values, so 6 plus 1 is giving you 7. The second element 2 plus 7, it is giving you 9. Similarly 89 plus 3 92, and 7 plus 4 11. Okay, so I hope you have understood the use of multi-dimensional arrays. Okay, similarly you can also deal with multi-dimensional arrays of more than 2. Like for example, you may even have arrays of 3-dimensional or 4-dimensional or even n-dimensional, right? So the difference is the same. There is as such no major difference over here. Let's say for example, if I just clear this out, clear the program, and it will look similarly. It can be declared in the same way, int a. So if it's a 3-dimensional matrix, you will have 3 subscripts, and the size will be mentioned over here. So this is an array of the subscripts. The first subscript is 3, the second subscript is 2, and the third subscript is 1. Okay, so it is actually like, it will be like a cube. Okay, so if you have ever seen a Rubik's cube, then that can be represented with a matrix or 3-dimensional matrix of 3 cross 3 cross 3. Okay, so basically there are 3 rows, 3 columns, and a depth of also 3, right? So that will be a 3 cross 3 cross 3 matrix. Similarly you can even have 4-dimensional matrices. Okay, 5-dimensional, like that. Okay, so the number of dimensions in your matrix will completely depend on the program for which you are finding the solution. Okay, so I hope you have understood the basics of arrays and how to use them properly. Okay, so in the next lecture we will start with strings and the uses of how we can handle strings and the library of string.h library. Okay, thank you. See you in the next lecture.